Hello guys, myself Sidling Kalburgi. I am here with a lesson electric current and its effect of 7th standard physics. Before going to the lesson, let us remember some terms we have learned in 6th standard. In the first one, electrical appliances. So electrical appliances are any appliances that runs on the electrical energy are called electrical appliances or the devices. Next thing, filament. So in bulbs we have studied the filament, right? A loose spiral of a very thin wire of high melting alloy or metal is called a filament. So what happens here in bulb? The filament is made up of alloy, right? When we pass electric current to the bulb, the filament gets heat up and produces light energy. So in bulb what happens? Electrical energy gets converted into light energy. Next is electrical fuse. So it is a safety device which prevents damage to the electrical appliances. So what a fuse is a safety device which prevents the damage to the electrical appliances. Next, electromagnet. A coil of insulated current carrying wire wound around a soft iron core is called electromagnet. So these things we have learnt in the 6th standard. So now we will study in the 7th standard. So now let us see the contents of electric current and its effect. So in that content, introduction, second one, symbol of some electrical components, third one, combination of cells, fourth one, electrical circuits and circuit diagrams, last fifth one, effects of electric current. So these are the contents, are the things, or the concept we are going to discuss in this lesson. Next, so here introduction. Electric current is the flow of electric charges. So already you have learned about the electric current in 6th standard. So that is nothing but the flow of electrical charges. So here charges means electrons. The flow of electrons constitute the electric current that you have studied in 6th standard, right? So this is the definition of electric current. So what the definition of electric current means? What? Electric current is the flow of electrical charges, right? So the SI unit of electric current is ampere. So here SI unit of electric current is ampere. So we use electricity for many purposes like to operate electrical pump, bulbs, television and to run the computers. So with the help of electric current, these are the things which runs or works, right? Electricity even help us to work at night also. So when dark is there, then at that time we will use the electricity to light up and the work should be completed. So this is electricity. So this electricity reaches our houses from the power station with the help of cables. So how electricity reaches us means, so it reaches us from power station with the help of what? Electrical cables. Next, so next is symbol of some electrical components. So here the symbol of some electrical components. So components such as cell, bulbs, wires, switches, etc. are called elements of an electrical circuit. So what are the elements of an electrical circuit? Means what? The bulb, cell, wire, switches, etc. and many other things are called the elements of an electrical circuit. So each element can be described by its symbol. So each of these have a different symbol that we are going to learn here. So first thing is electrical cell. So see the figure of electrical cell and the symbol also I have shown in the diagram. So see the figure there, that battery has positive and negative terminal and the symbol for it is also I have shown, right? An electric cell represented by a set of two short vertical lines. So it is represented by set of two short vertical lines. So here, so one of them is slightly shorter and thicker than the other. So in that one of them is slightly shorter and thicker. The larger line represents the positive terminal. So here a larger line represents which terminal? Positive terminal, and the shorter line represents the negative terminal of the cell, right? So the larger line represents positive terminal and shorter line represents negative terminal. Okay, the cell is a device which stores a small amount of electric current. So this is the definition of cell. So it is the device which stores the small amount of electric current in it. So next is battery. See the figure and the symbol of the battery there I have shown, right? So battery is combination of two or more cells. So see their figure also, it is the combination of two or more cells. The cells can be connected in two ways as shown in the figure, right? So the cells we are going to connect in two ways that I have shown in the figure. So next thing is electric bulb. So the figure and symbol of electric bulb I have shown there, right? But what a symbol of the electric bulb I have shown them. An electric bulb represented by a circle with a curved wire inside it. So that is M shaped. See there, it is the circle represented with a curved line. So it seems like a M shaped, right? The curved wire represents the filament of the bulb. So whatever may be the curved wire, that represents the filament of the bulb. The filament glows when an electric current passes through the circuit. Right? When filament glows, when the current passes through the circuit, then the filament glows, and what happens? Light energy produces. Right? Electric bulb is a device which converts what? Electrical energy into light energy. This again we are discussing here. So this was also 19th standard, right? Next is connecting wires, right? So see diagram and symbol of the connecting wire, right? See there the diagram and symbol of the connecting wires. So connecting wires are represented by a straight line. So see here connecting wires are represented by straight lines. Generally connecting wires are made up of copper. So connecting wires are represented by straight lines, and the connecting wires are made up of copper, right? The wires are used to connect various electrical components in any circuit. So these wires are used to connect the various or other electrical components in an electrical circuit, in an electrical circuit or in any other electrical circuit. Next is wire connected together. So see the diagram there, two wires are connected together, right? And the symbol also I have shown there, right? So see the diagram and the symbol of the wire connected together. The connection between the two wires is represented by a dot. So here the connection between the two wires is represented by a dot. This is the symbol, right? Dot at the connecting point. So at the point we have shown a dot, right? So this is the wire connected together. Next is switch on and switch off, right? Students, see the diagram and the symbol of a switch, right? So each switch has 2 points. So each switch has 2 points. See there is 2 points. When the 2 points are connected, this circuit remains open. So when 2 points are not connected, then this circuit remains open, right? This position of switch is commonly called as off position. So this circuit remains when open, then there is no flow of electric current, then the circuit is called as off position, or else then the switch is known as off, right? So next, when 2 points in a switch are connected, the circuit gets closed. So when both the points are connected, then the circuit gets closed, right? This position of a switch is commonly called as on position. So it is called as on position when the circuit is closed, then the current flows through the circuit. So that's why it is called as a on position. In this position, current flows through the circuit. Now I told that what at that position, the current flows through the circuit. Next, a switch is a device that breaks or connects the electrical circuit. So switch is a device that what it makes, that breaks or connects the circuit. Next, so next is electric fuse. Students, see the diagram and symbol of a fuse, right? A fuse is a thin wire of an alloy having low melting point. So fuse is a thin wire of alloy having low melting point. A fuse is always connected in a live wire. So it means when current is there, at that wire only a fuse is connected, right? A fuse of a proper rating should be used. A fuse may be used for a proper rating. Next, combination of cells. So each cell has a specified weightage. So weightage means an amount of electrical power expressed in watts. So weightage means what? An amount of electrical power, whatever may be the power it has. So this expressed in watt, or else the operating power of a lamp or the other electrical appliances expressed in watts. That is known as weightage, right? We are going to define the weightage in two forms, right? An amount of electrical power expressed in watt, that is also called as weightage, or else the operating power of any electrical appliances that is expressed in watt is called as weightage, right? So each cell has 1.5 volt of voltage and capacity of 1.1 milliampere per hour of current, right? So every cell has 1.5 volt of voltage and it has the capacity to produce 1.1 milliampere of current, right? Therefore cells can generate a fixed amount of current. So it means cell can generate a fixed amount of current and voltage. To obtain higher weightage, right? To obtain higher weightage, what we have to do? Two or more cells are joined. In such a combination of cells is called battery. So when two or more cells are joined together, so that combination of cell is called battery. Next, so next arrangement 1. So here in combination arrangement 1. So in one of such a combination, the cells are placed one after the other, connecting negative terminal of one to the positive terminal of the other. So see here in arrangement 1, negative terminal of the battery is connected to the positive terminal of the other battery. So this type of arrangement is called a series combination. So this type of arrangement is called a series combination. So these you are going to learn in higher classes. No need to worry about this, right? So this combination leaves one positive terminal, that is positive, and one negative terminal, that is minus, free for connecting the battery to the other components of electrical circuit. So here this combination of cell that leaves one positive terminal and one negative terminal. So that is used for the connecting for the other electrical appliances. So see the diagram shown below, that a battery of 2 cells and a battery of 3 cells, right? It is the combination of 2 cells and 3 cells. See carefully guys, here each cells are placed as I told earlier is negative and positive terminals, leaving one positive and one negative terminals, right? So next arrangement 2. So in arrangement 2, certain electrical appliances, right, the cells are placed side by side in a compartment and the cells are connected to each other with the help of metal strip or thick wire. So you have seen the remote that the cells are placed side by side, right? So with the help of what? Compartment. So that is a compartment. That what? Remote is a compartment that we are placing the cells side by side with the help of metallic strip or metal strip is there inside the that remote, right? Remote is an example for this arrangement. So see diagram guys, this arrangement also leaves one positive and one negative terminal, right? So by seeing this diagram also we will come to know that this arrangement will also leaves what? One positive terminal and one negative terminal. Okay guys, today we have discussed this concept. So next class we will study about the electrical circuit and circuit diagrams. I hope you guys enjoyed this class.